Wednesday workshop where we get together in the middle of the week and talk some tech. We're always pleased to see so many of you join us, especially on our Learning Linux. We've got a very good number of people here that's going to join us as we learn about headless Raspberry Pis. Our guest presenter today is somebody who's not new to our workshops. He's a full-time attendee, but we finally got him to agree to do a presentation, and that's going to be Curt Trout. And Curt Trout is active with the Twin Cities PC Users Group, and he got into that group about 1988 after having purchased a family Christmas present, an IBM AT clone. He served many years on the board of directors and currently serves as the TCPC, Twin Cities Personal Computer Club, as their vice president. And he wants everybody to know to make sure you don't miss election night, because he did, and he got elected vice president. He's also their webmaster. Curt also wrote a monthly column for the TCPC newsletter titled The Frugal Computer. Along with his wife, he has formed a company called Trout Reach Technologies, and they help build websites for small churches and parachurch organizations, along with serving small businesses. Now, Curt would tell you that in the very, very beginning, he started out as a auto mechanic, but United States Navy said, hey, we got better things for you. And so with his computer background, he became a member his computer background started as a member of the U.S. Navy, where he served as an electronics technician, that's for radar, and he supported communications equipment. After leaving the service, he went back to school, changed his major from pre-mechanical engineering to mathematics with an emphasis in computer science after having fallen in love with computers. He's had a variety of technology experiences, including running a computer laboratory, learning many programming languages, worked for a short time as an applications programmer, was a senior systems engineer for a large IBM plug-compatible mainframe manufacturer, and he retired after almost 26 years of being a senior systems programmer supporting large IBM mainframes for a large multi-state banking organization. And now he has a lot of free time to work and play with computers. And so today he's going to be sharing one of his hobbies with us, Raspberry Pi without a head. So Curt, it's all yours.
Thank you very much, and good morning, everybody. I hope that I can make this next hour or so both entertaining and educational. So give me a second to do a little switching around here and share the right screen. Okay. This morning, what is our objective here? Come on. Okay. To teach and show how easy it is to add a Raspberry Pi into your home network. Created a little bit of an agenda here to see where we're going to go. These titles here don't exactly line up with the slides, but they give you an overview of what we're going to do. What typical PCs require. What I'm going to assume about your home infrastructure. We'll look at a little bit of the history of the Raspberry Pi. We'll talk about getting started, and then through a couple of videos, only because some of the steps in them take a little bit of time to run, we're going to take and build an image for a Raspberry Pi. We're going to boot it for the first time, make some configuration changes that we need to do and that we can only do from running it. Then we're going to boot it again and connect with VNC Viewer. We'll show some interesting links, and I have a challenge for you. Then we'll take time for questions and discussion. And if time allows, John said he likes to see live demonstrations, because then you can see errors pop up as opposed to the recorded ones where everything seems to work. Well, the recordings aren't perfect, but they do work. And the main reason that I recorded them is that a couple of them involve doing something for the first time, and some not really error messages, but messages that you will see because you have never connected either using a terminal or using VNC. So with that, how do we learn how to do something? You know, there's a bunch of ways we can do it. We can read about things, and that's appropriate if we, you know, can understand what we're reading. We can watch somebody else do it, which also, you know, if we think we can learn enough to do it ourselves from that, we can do it, or we can do it ourselves. And the you know, the examples for that, you know, if we want to drive a car, we've got to drive it. You know, if you want to learn to drive a car, you have to drive a car. If you want to learn to ride a bicycle, you got to ride a bicycle. Okay, so doing something is the way to do it. And some of you, in fact, I think there is one person in this meeting that I know of, has a Raspberry Pi sitting in his home somewhere that he bought sometime, but hasn't done anything to it. And I think I know why that may be, and we'll take and eliminate those excuses today. So for the PC that you are probably looking at right now, you know, or to run a PC at home, you need the computer. Okay, you need space for it on your desk, preferably. Even if it's a laptop, it needs the space for that laptop. It needs a source of power. It needs a network connection. And as many of us have learned over the years, what does PC stand for? It's not personal computer. It's plenty of cables. Okay. I thought about taking a picture of the rat's nest of cables underneath my desk, but then thought better of it. So I'm going to assume right now that you have a personal computer running Windows, Mac OS, or Linux. Doesn't make any difference to us. That you have a local area network that's connected to the internet. Okay. If it's wired, you have an available port on a router, hub, or switch that is in your network. Okay. If it's wireless, you need to know the network SSID and password. And if you're watching this right now, you've got all of these covered. Okay. You'll also need a place for the Raspberry Pi, close enough to power so that you can plug it in. Okay. And if your network is a wired network, and that's perfectly acceptable for our purposes here, then you need to have it close enough to a port and a cable to do it. But none of these requirements are particularly stringent. A brief history of the Raspberry Pi. The development actually started in 2006. And the first released model of a Raspberry Pi was the Raspberry Pi B in 2012. It's a single board computer, okay? Everything but the power supply and peripherals, keyboard, mouse, etc., is fabricated on a single printed circuit board. Some models support wired or wireless networking and Bluetooth. I've never used Bluetooth on one of mine, but certainly wired and wireless networking. And the original aim was to have an inexpensive computer to teach computer science in schools in developing countries. So the idea was to take and produce a small, inexpensive computer that could be used for teaching. The original model became much more popular than anticipated and sold widely outside of the target market. And this is somewhat analogous to the computers from that itty bitty monopoly called IBM. They anticipated that the market for their computers might be 5 computers back in the 1950s and 60s, and they're still going strong today. And they kept me employed for a lot of years. Okay, so we're going to run a Raspberry Pi. Come on. Which Pi models will suit our needs? What can we use? And the quick answer is almost any of them. And that depending upon what you want to do with the Pi, that has a bearing on which model you might choose. There are a couple of current courses or choices. We'll talk about them in just a minute, okay? But for our purposes here, any model with onboard networking, okay? And if you have a model that does not have onboard networking, you can plug in a USB Wi-Fi adapter. I have done that. The ones that I have used, I don't know if I've been lucky or not, or it's just that they're so well supported by the Linux, but you plug them in and they're there. Right now, though, there's a big problem with not only baby formula, but Raspberry Pis. And new Pis right now are made from 100% unobtainium. Okay, you cannot find them. They are being manufactured in small quantities as chips are available, but they're getting snapped up as soon as they hit somebody's shelves or for pre-orders. There is a website now called rpilocator.com, I believe, maybe it's a .net, that actually shows the availability, or actually the unavailability, of Raspberry Pis from a large number of vendors. A couple of weeks ago, there were a couple of vendors in Europe that might have had a couple, and there was one vendor that had a Raspberry Pi 4 compute module. And that would not really be suitable for what we want to do right now. So let's take a look at a couple Raspberry Pi models. This is the current little Raspberry Pi. It's a Raspberry Pi 02W, and oh, how I hate that name because it is so darn long, okay? It is a Pi Zero, the littlest one, which was certainly not the first one, okay? And the 2 indicates it's a second model of that. The W indicates that it is wireless. We're actually going to be using one of these. I don't know how I happened to come upon it, but I was looking at a Micro Center ad and they had a Pi 02W available, and I snapped it up. Had them lay it away for me until I could get over it. The original Pi Zero cost $5. You also sometimes see an interesting pricing model where if you buy one, it is $15. If you want to buy 2 to 5 of them, it'll be something more than that. And the idea for that model was to make them available as learning tools, but not to allow companies to snap them up for other purposes. Okay. One of the things that differentiates some models of Pis, in addition to their processing power and capabilities, are the connectors that are on them. Okay, looking at this one, we have a slot for an SD card. This is the Pi Zero is a little bit unique in that this slot is on the top of the card. Most models have this underneath the card. Okay. One of these is for power. Okay. One of them is a USB port, and this is an HDMI connector. So you could connect a monitor to it. There are onboard connectors. I believe this is for a camera. I am not absolutely certain of that. I don't have any Raspberry Pi cameras though. This is a nice little tool if you want to learn. It's inexpensive. You don't need much more than that. Most of my Raspberry Pis that I've used, I power with cell phone chargers. I've got some Samsung 2-amp chargers, and they work just fine for everything except Raspberry Pi 4s. Okay. They actually meet the requirements for the Pi 4, but the Pi 4 complains about it anyway. I do not know why. And speaking of Pi 4s, here's the current generation. Okay. This is the first Raspberry Pi that actually has choices to you in the amount of RAM. Okay, and the pricing structure was such that the current model of the Raspberry Pi has always been available for, I believe, $35. And when a new Raspberry Pi is announced, what frequently happens is the old current one drops in price by about $5, maybe even 10 from that. And I think that's probably so that people have the best experience. Something that you will find on the Raspberry Pi website for each of their models is a statement of support. And what it says is, we will make this model available until. And I think for the current Raspberry Pi 4s, that's something like 2026 or 2028. We'll keep making them, okay? All of the Raspberry Pi 4s look sort of like this, okay? They have onboard gigabit Ethernet. They have 2 USB 3 ports. They have 2 USB 2 ports. They have 2 micro HDMI ports that it'll support 2 monitors, both running in 4K mode. Okay, and here's the USB-C connector for the power supply. Raspberry Pi 4s are the only model that I have always gotten a case for, one form or another. And I do that primarily for 2 reasons, okay? I can buy a package that has a case, which is handy to have, okay, and a power supply, and frequently a power supply that has an on-off button in the cord, okay? You'll note that there are no on-off buttons on a Raspberry Pi. There are some ways you can program your Pi to have a power or a shutdown button on them, but there's no really quick and easy way to put a power button on the Pi itself. Okay, so 4 Raspberry Pi 4s, they run hotter. So I usually get a case for them so I can have something that'll hold a fan. This is the processor. It needs to be cooled. The RAM needs to be cooled, and I believe the network chip, which is one of these, I don't remember which one, also is a little bit sensitive to heat. So if you buy a case, especially if you buy one that has a power supply, because you can get a pretty good deal for that way, you get a fan, a case that'll hold it, heat sinks for those 3 chips, and it's not a terrible expense. It's about $20. If you wanted to, you could probably use that same case for any model Raspberry Pi other than the Pi Zeros. Okay. Let's get started. What do we need? We need a Raspberry Pi that supports networking. Okay, so that's either inherently, or if we have a USB port on one with a USB Wi-Fi adapter. Okay, we need a suitable SD card. The size of it is sort of dependent upon what you want to do with it. The operating system itself will be real happy and a lot less than 8 gigabytes. But when we start taking and adding other files to it, if you want to collect photos with it, if you want to use it as a network file server or something like that, you may want more storage on the SD card. So I usually use 32 gigabit cards as a minimum. Something interesting happened to me a couple of days ago. One of my SD cards actually died on me. I could do a quick format on it, but I couldn't write to it beyond that. So I built that same image, and the card that I pulled out of the box happened to be a 64 gig card, and works just fine. Okay. You need a power supply for it. I talked about cases; they are not necessary. One of my favorite cases for less than Pi 4s is a clamshell type soap dish. Okay, the kind that you can get from Wally World for less than $1, the kind that have a hinge on them. One of those cases and a Dremel tool, cutting blade on that, work really, really nice. I've got the Pi that's running in my home's Pi hole sitting in one of those cases right now, and it's out of the way. Okay. Like I say, they're not necessary. You can buy them commercially. I do that particularly when I want to get a fan along with it. If you've got a 3D printer, you can print your own. And like I said, found objects work well. I may turn on the camera a little bit later, and I'll show you that I've got a Pi 02W that is running very happily inside of a former prescription pill bottle. Okay. Okay. I talked about fans and heat sinks. So the most daunting slide that you are going to see today is this one. Okay. There is a handout for this. You don't need to write down all of these links. Judy's going to send it out after the meeting, but we need to take and put some software on our computers so that we can build an image for our Raspberry Pi and then talk to it from our desktop computers. If you're a Windows user, then you need a program called PuTTY, P-U-T-T-Y. The significance here is the TTY. It is a terminal program. Okay. It is available for free. There is a version of this on the Windows application store, the Microsoft store, whatever it is. Don't get it from there. Somebody took what is still the current version of it and jumped through Microsoft hoops to get it in that store because he wanted to install it on a Windows S machine. Okay. I doubt that any of you are running that. Don't get PuTTY from there. Use this link. Okay. Mac and Linux users can use the terminal application. Okay. You need a VNC viewer, and that's true for everybody. Okay. The standard one to use, and I think there's some others out there, is from a company called Real VNC. Okay. This viewer is available for all platforms. Okay. VNC or the company, Real VNC, makes other products that they sell. One of the things that they sell is a VNC server and upgraded versions of the VNC viewer. The big drawback in the viewer that we're going to be using right now is that it does not handle sound. We can see what's going on the other computer. We can control it. We just can't get that sound back to our desktop. I have never found that a problem because I've never done anything on my Raspberry Pi that requires that I listen to it. Okay. Next, we need an imaging program. We used to use a program called Balena Etcher. It is still a good program. It will still work, but the Raspberry Pi Imager from the Raspberry Pi organization is now a much better tool. To those friends of mine that saw an earlier presentation, sort of like this, that I did for TCPC, I kind of apologize because I showed you a method that didn't use the Raspberry Pi Imager on that. Recent versions of it have added a facility, we'll see it in a little bit, that make building an image for a headless Pi a whole lot easier. Okay, we don't have to build special files and put an image of the chip and then modify the files and whatnot to get it to connect. Okay. You're going to need a Raspberry Pi system image. Now, you'll see in a video that's coming up that you can tell the imager to download a copy of your selected operating system while it's doing the imaging. That is sort of like watching paint dry. It is really, really, really slow. Okay, so I don't recommend doing that. For every image that the option that we have, if we look at the download instructions for it, we'll see a little thing that says archive. And the archive was put there primarily in case you wanted to get an older copy of the Raspberry Pi OS. But it also includes the current one. And I haven't investigated all of the details, but if you download from that archive, it'll come down really quick. Okay, the biggest file that we're downloading is a little over 2 gigabytes, I think. There are, where is it coming up? Yes. We'll talk about what version. There are 3 versions of the Raspberry Pi OS that you may be interested in. Maybe 2, and I'll tell you what my recommendation is. I recommend, though, that you download all 3 of them. Doesn't take very long. So this is the hard part, and nothing on here is difficult to do if you've ever installed a piece of software on your computer. So, okay. There are 3 current versions in sort of 2 flavors. Okay. All Raspberry Pis will operate in 32-bit mode. Some of the newer ones, including Raspberry Pi 4s, I think some Raspberry Pi 3s, and the Raspberry Pi 02W, will operate in 64-bit mode. But there is no compelling reason to run 64-bit mode. It's not going to run faster. Okay, it is going to take up a little bit more resources, and therefore pick a 32-bit version. Okay, the Raspberry Pi OS with desktop. This is sort of the middle of the scale of in size of the 3. It will give us a Raspberry Pi 3 that has a desktop interface on it. It does not have a lot of things that we don't need. It used to include LibreOffice. It does not now, but it's easy to add. Okay, I found that out just recently. Okay, the Raspberry Pi OS desktop with recommended software. Now, the recommended software is Raspberry Pi's organization's recommendation. It's not everything but the kitchen sink, but a whole lot of everything. If you don't want to install LibreOffice, you know, you can pick this one because it'll be there. And there's some other things there that you might want, but I think the one with just the desktop is appropriate. Like I said before, that one is a little over 2 gigabytes to download. The Raspberry Pi OS with desktop is about a little under 900 megabytes, if I remember right. Raspberry Pi OS Lite does not have a desktop. If you want to do something on your Raspberry Pi from the command line, this is probably the version that you want. Us Windows and Mac users kind of get lost if we don't have a desktop to fall back on. So the one that I recommend, and the one that you'll see here today, me using a little bit later, is the Raspberry Pi OS with desktop. Okay, this is to bring back some memories to those of you who saw my earlier presentation, and this used to be the way we would do it. We would build the image with Imager or Balena. Then with that micro SD card still in our computer, we would add a file called SSL. Didn't have to have anything in it, just had to exist. A file called config.txt that defined the, I've got a missing parenthesis, told the Raspberry Pi the characteristics of a terminal that he would have if he had a terminal. Since we're not going to have a terminal in our Headless Pi, we needed to provide that. And WPA supplicant.conf is a file, I believe, supported by most Debian and Ubuntu-based Linux distributions, that allows us to take and define a Wi-Fi configuration to be used the first time the operating system boots. And if that is successful as part of the boot process, that file will be erased. Okay, it gets us on our network for the first time, and that's it. This is something you don't want to go through if you don't have to. So how do we do it now? Okay, we downloaded, those 3 programs and our images earlier. So we start the Raspberry Pi Imager. We select which one of the ones we downloaded that you like, that we're going to use. Okay. We insert your SD card into your computer, not the Raspberry Pi, but your computer. Okay. And now with Imager, you run Imager, we pick the version that we want to install. Okay. We select the SD card on our computer where we want to write it to. If you have other USB connected storage devices, whatever they might be, okay, whether they're thumb drives or external drives, be careful, because you want to make sure that you pick the USB drive, okay, that is the one you want to write to. So let's do it. And I'll stutter through the way, but I've got the Raspberry Pi Imager running here. The first thing to do is to choose an OS, that is the system we want to write. Okay. I could use the option. Now, is everybody hearing me?
Yes.
Okay, thank you. That are up here at the top, but I prefer not to do that. This will download the latest versions from the Raspberry Pi website, but it doesn't save the file that gets downloaded for future use. Instead, I prefer to go all the way down to the bottom and click Use Custom. Then we'll take and navigate to where I saved the images that I downloaded. I downloaded all 3 versions. Now, I am going to click the standard image. That is not the full and not the light. This is a little bit of a compromise, but it'll let us do everything that we want to do. It'll give us a desktop. It'll include things like LibreOffice. So we'll select that and open it. The next thing to do is to choose a storage device. This will be a USB drive. It'll be your SD card. You need to have that inserted now. My choice is simple. I only have one USB drive on the system right now, and that's the 32 gig SD card that I'm going to write to. So we'll select that. And now this gear icon appears. This is a big deal. This is sort of revolutionizes how we can take and set up our card in a simple way. So I'm going to click that, and we get a dialog box up here. I've got this expanded to show all of the options, and instead of going through and setting them, I'm going to just talk about what they are. The first thing is the host name. That can be anything that we want. Convention is to use all lowercase characters. You can use numbers. You can use, I believe, hyphens and underscores. You can't use spaces. That's going to identify the machine. And that's important because that's how we are going to find our Raspberry Pi when we boot it, okay? We're going to use SSH to encrypt our connection to it and use password authentication. That's certainly more than sufficient for our needs. This is running in our home network, okay? We want to set a username for the primary user of this Raspberry Pi. In past versions, the default user used to be Pi with a password of Raspberry. And the trend right now, and in fact, it's being forced upon Raspberry Pi in some parts of the world, is to eliminate that default logon and password. So we're going to set our own password. I just chose Curt, and I set a password. You can't see that here because it's coming from a saved list. I could take and change it, but I am not going to. Okay. I'm going to choose to use a wireless connection. Okay. If you are using a wireless connection, then we want to configure the wireless LAN. We need to do this so that when our Raspberry Pi boots up, it'll be able to connect into our network. Select an SSID for your network. If your router does not broadcast its SSID name, click the hidden SSID and enter your password. One thing I will point out to you, if you are using a Raspberry Pi 02W, okay, the SSID that you connect to must operate in the 2.4 gigahertz band. Okay, that may have a bearing on the network that you connect to. For all intents and purposes, the band is unimportant. It'll operate at speeds that we expect. Okay, if you are not in the U.S., then you want to indicate your company. Okay, that's this has to do with the channels that your Pi is going to operate in, the frequencies. Set locale settings. I'm in the St. Paul area, the same time zone as Chicago, so I'll use that. Pick whatever is appropriate to you. And you can probably, considering the audience that I have, say the keyboard layout is US. Okay. The persistent settings down here are not terribly important. The play sound when finished will take and give us a little sound when we're through writing our image. I'll be honest, I've always had it set and I've never heard it. And the reason is that the writing process takes a while, and usually I take advantage of that time to go do something else. Okay. Eject media when finished is handy. Okay. when an SD card is inserted, when you want to, if you write anything to it, when you eject it, you need to have the operating system recognize that the card is going to be ejected before it gets removed. This is that logical ejection, and make sure that everything on the card has finished writing before the card can be removed. So if we click this, it will take and go through the process of closing off that drive, so that to the operating system, it'll be the same as if it had been removed. We can simply remove it. And then enable telemetry is something that I will never check. Nobody needs to keep tracking of how we're using this. So we'll save our settings. Okay. Make sure you know what you set for your user ID and password, and save them. And now click Write. Okay. This is a warning to tell me that everything on that card is going to be erased. Do I want to continue? Yes, I do. And we are about to start writing onto the drive. Okay. This process will take a few minutes. The data will be written. When it's completed writing, it's going to go back and verify it, and then it's going to do the eject and tell you that you can use it. That's not fun to watch. I timed this once for the version with recommended software, the largest version of it. I think it took somewhere between 20 and 30 minutes. So with that, I'm going to take and stop this recording. I think I may have an error in my deck here. We'll see. I've got the Raspberry Pi imager running here. The first thing to do is to choose. That was an oops. We've written our image onto the SD card, so we can now take and boot our Pi. It's not quite ready to use yet. Okay. What we have done by loading the image to it and using those options, okay, is we've allowed the Pi to connect to our network and to start SSH so that we can connect to it from our computer. But there is no graphical interface in running yet. And we're maybe behind on software. We're going to defer that for our purposes here. But we also need to tell the Pi that when it boots, we want the VNC server to start. That's so that we can connect with the VNC viewer. Okay, so we boot our computer for the first time. My Raspberry Pi has been powered up, and on my desktop computer now, I'm going to start, or I have started, PuTTY. We're now going to use SSH through PuTTY to connect to the Raspberry Pi. Now, we can use either the IP address, and I haven't bothered to go find it, or the host name. So I'm going to enter the host name here. And tell it to open the connection. Don't forget that .local. That generates a security alert the first time we do this, because PuTTY on my computer has not seen the new machine. So I'm going to accept the key. And now PuTTY's giving me a little bit of a test here. And now I can log in. hope that I entered it right. And I have. Okay, so this is a terminal window now. It's running on my Raspberry Pi. I'm looking at it on my desktop computer. I'm going to run a program called Raspi-Config. Now, Raspi-Config requires super user authority in order to run. I am an administrator on here, but in order to take and run as the super user, I have to explicitly do that. And we do that with a command called sudo, which stands for super user do. Okay, Raspi config. And now we're looking at the options for Raspi config. There are two things we want to change here. In the display section, scroll down to it and hit enter will take me into it. I want to set the VNC resolution. Okay. When we go to connect with VNC, we have to tell VNC what the resolution we have. If we had a real monitor connected to our Raspberry Pi, it would interrogate the monitor to get its resolution and characteristics. So we're going to set it. My monitor is 1920 by 1080. That's what I'm going to choose. Okay. Choose something that is appropriate for the monitor that you're using. You don't have to take and make it full size. In fact, there might be an advantage to setting it something smaller. What you probably want to do is to make it reasonably large and with the same aspect ratio as your monitor. So, excuse me. I've got the resolution that I want set. I'm going to use the tab key to go to select that. It'll give me a confirmation message, and I can just hit enter to do that. And that takes me back to the Raspi-Config menu. One other thing that I need to do here is to check the interface options. Now, in particular, pardon me, SSH has already been enabled to start when we boot. We need to take and start the VNC server when this system boots. So we'll go to VNC. Would you like the VNC server to enable? Why, yes, I would. Okay. It's confirming that that's been done. Okay. We are now finished with what we need to do within Raspi-Config. So we're going to tab, I can hit the right key. Okay, I'm going to finish with Raspi-Config. We'll press enter. And since we've changed things, particularly the fact that we've changed things that are going to affect startup, we need to reboot now. So I'm going to say yes, we'll do that. Okay, this message that we just got now is because the Raspberry Pi just shut down and is now rebooting, and that's quite all right. We're gonna stop the share, and we're gonna stop this meeting or this recording. My Raspberry Pi has been powered up. Okay, we had a duplicated slide in there. Now we're going to take and our Raspberry Pi has been rebooted. Now we can connect to it with VNC. So the Raspberry Pi is running VNC server. The viewer is on my PC. My Raspberry Pi has been rebooted. Now I'm on my computer. I've started up VNC viewer, and I need to make a connection now to the Raspberry Pi. I'm going to right click anywhere here to create a new connection. Get a dialog box for that. And I need the IP address or the name of it. The name is convenient. And I can give it a friendly identifier that'll take and show up in my list of connections here. And say, okay, that'll create a connection here, but it will not open it automatically. Now we're going to do a little bit of, I'm going to click on this and do a little bit of shuffling with the screen share and be back in just a second. Okay, I got another pop-up window. I got a pop-up window here asking for details in order to connect to my, the APCUG local Raspberry Pi. These are the same credentials that I've been using all along. I'm going to tell VNC Viewer to remember these credentials. And at last, we're now looking at the desktop on our Raspberry Pi. Set up the way we had everything running on here. We have program applications running. It's a fully functional machine. Excuse me. There is one other thing that I like to do. This is the terminal window, or the terminal on the Raspberry Pi. We're going to open it up. And I don't know about you, but my old eyes have an awful lot of trouble reading what's inside here. So we're going to take and edit preferences on this window. The first thing that we're going to do is modify the terminal font. Okay, we're going to make it a bunch bigger. That ought to do nicely. And I do not like, select it. Okay, and I do not like white text on a black background. The contrast is way too much. So we're going to take the background and we're going to lighten it up a bit, quite a bit. You can use the color if you want. I'm going to take this sort of medium gray. Which should be selected. And the foreground color, I'm going to set to be white. And we should be set there. And now and that will be saved. We can drag this window out when we want to use it. And I'll just close this and we'll open it back up. And my settings were saved. And we'll close it. Okay. I should take and run updates on this Raspberry Pi. Right now, update the software for any maintenance that's come out since the distribution was done, but we're not going to take time to do that tonight. My Raspberry Pi has been rebooted. I thought there was an error in my slide deck that was mine before. I'm now convinced that it is PowerPoint's. Okay. Just like other operating systems, there are regular maintenance for the Raspberry Pi OS. To do that, you open a command window and enter these two commands. We may be doing a Pi-hole installation a little bit later today, so I put the command for that here. And maybe I'll take a moment to explain what this command is doing. Like probably all Linux commands, options are case sensitive. So we're going to run a curl command first. Curl, these are options for it, and quite frankly, I don't know what they mean. Okay, but this is the published way to install it. Hyphen small s, capital L, https://install.pi-hole.net. Okay, what curl does is it goes out to the website that we reference, and it downloads that web page, for lack of a better term. Okay, these options determine what's going to happen with that. The vertical bar here is what's called the pipe command, or the pipe symbol, and that says download what is here, okay, into a file on my computer, and then take that file and input it to bash. Okay, bash is a command processor. Okay, this is the thing that executes our commands when we're in a terminal window. So what this does is it takes this installation script, reads it, dumps it down an internal port that we have to the command processor on our machine, and installs, in this case, Pi-hole. Okay. There is an argument that says you should never use this installation method because you're installing something, you're running commands that you can't see. There are some manual ways of do that. They're beyond what we want to talk about. Okay. Some interesting links. There's a lot of stuff on YouTube about Raspberry Pis. One that I sometimes read Jeff Geerling's, watch his presentations. And one I saw earlier this year particularly caught my attention. I listened to it. And when he got to the last one, I was a little bit surprised at his top Raspberry Pi project. I think you'll find it interesting. Explaining computers, and there's no space in there for a reason, okay, is another site that I watch. I can't think of the fellow's name. It's Christopher something or other. That explains computer topics in a pretty good way, okay? And he has a video about the top 10 uses for Raspberry Pi. They are different, okay? And finally, Judy Tulor sent me a link of the top of the 10 best Raspberry Pi projects for beginners, and it's from Make Use Of, okay? This is Judy's recommendation, not necessarily mine, but there's nothing wrong with it, okay? Take a look at it. You may find it interesting. Now, you've got your Pi, you've got it set up. Maybe you've got Pi-hole running on it. In fact, I hope you have Pi-hole running on it, because I have a challenge for you. Okay. I would like to configure my Pi-hole server as a recursive DNS server. To do that, after you've installed Raspberry Pi, the Raspberry, Pi-hole. Let me get the terms right here. You install Unbound. And I have gone through that process, I don't know how many times, and it works perfectly up to the point where I configure Pi-hole to talk to Unbound. And at that point, it just breaks and stops working. So if somebody out there can tell me how to get this thing to work, I'd appreciate it, or figure out what I'm doing wrong. So with that, okay, it's time for your questions. I'm going to stop my share and turn my video back on. And Judy, I think the floor is yours to start.
Thank you. For electrostatic charge protection when using a digital board, how do we ground ourselves on the board to prevent damage to it and electric shock?
The best practice is to handle the board by the edges and don't worry about grounding yourself.
Does the Raspberry Pi need a sound blaster?
The Raspberry Pi, I'm not quite sure what you mean by a sound blaster. There is an audio, there are two choices of handling audio from the Raspberry Pi. By default, the Pi will take and make audio available on that audio jack that we didn't pay much attention to describing from on the board itself. So if you're close to it, you could take and connect your audio system to that. In fact, that might be the best way to go. If you have a real HDMI monitor connected to your Pi, and nothing that we did here today precludes you from doing that, okay? Then you can have the audio come out via HDMI, in which case your television's audio will, your television will play whatever audio is on the Pi.
Okay, over to Jerry Crow. Unmute, please.
Oh, there we go. It told me I couldn't do it.
Right, because I hadn't set it up so you could, because
I thought that's
Judy
fine.
didn't tell me we're opening it up.
You should have had it clamped down. I have two questions. I want to understand this BNC stuff. First of all, I have a Pi right here in my hand. I have it set up. It's a B with a case, and I've played with it. I've got the OS installed, and I have an external monitor, everything external. I just hook it up, an external keyboard, mouse, everything. However, I think you described a manner in which I can use my Windows machine and go through to the Pi if it's on the network. Is that correct?
That is absolutely correct.
That would be a lot less work because I have anyway, I use a HDMI to VGA connector and put on the back of my monitor. Okay, so I should concentrate on that.
Let me interrupt you for just a second. That's part of the whole point of the headless Raspberry Pi. Because if we want to set it up as like we would set up another computer and add it into our environment, then we've got to cable it up. We've got to connect it to a monitor. We might need to use a KVM to switch our devices. The whole point of this presentation is to set up the Raspberry Pi headless. And I apologize. The slide I should have carried over from the original one. What's a headless computer? A headless computer is one that does not have a monitor.
Okay.
It does not have a keyboard. It does not have a mouse. All of those things that we normally use to communicate with it aren't there. So.
All right. So if I power my Pi up, the B, it's a Model 4 or whatever, I don't know. You got a picture of it there. It's got the 4 USBs and network connection.
Yep.
If I power that up and put it on a port on the back of my router, then I should be able to use the VNC and the other thing to get into it.
Absolutely.
Okay, I'll play with that. I'm confident I can figure that out. So,
It requires two things, okay? There's no first or second here. On your Raspberry Pi, and you can run Raspi-Config on the Pi, and in fact, that's what we were doing. You need to set it so that the VNC server starts when your Raspberry Pi starts.
okay,
Okay. Then you need to install a VNC client on your other desktop machine. Okay. And now you can connect to it. They have to be on the same network.
and the VNC client has to go on my Windows 10. Okay, all right. So there isn't a client, I assume, available for Windows 10. So
There was, and if you go back to that, the daunting page, and Judy's gonna send a couple of things out. Actually, maybe it's only one thing, 2-page document. The first page of it is a list of that software, the things that you need to download. And the second, which you don't need, but other people might, is if you're using the Raspberry Pi Imager, which I highly recommend. In fact, this presentation is all based upon doing that. Then there is, on page 2 is a worksheet. If you print it off, you can take and write down what you used. Okay. I have a great habit of taking and selecting a username that I don't use consistently and a password, and they don't have to be secure. They're only on our home network. So if we can't, if intruders can't get into your home network, we don't have to worry about them here. But I forget the password, or I forget the capitalization that I used in the password. That's why I provided that crib sheet where you can print it off and you can write down what you used. Okay, you can collect things if you don't know your Wi-Fi network's SSID. You can collect that. You can collect your Wi-Fi password and put it in there.
okay, yeah, I'm all wired. I don't use Wi-Fi, but okay, thank you. I understand now. So I use the Raspberry Pi configuration program to image my SD card. So yeah.
Yep.
Thank you.
And you want to use a current version of that. I don't know at what point they gave you that option screen, but it was not there at 1.4. I learned that lesson painfully.
Well, I can go out. Can I do was there an option within the OS in Pi to update the operating system itself, or just apps?
Yes, and in fact, you should do that. Okay, but if you are building a new SD card for your Raspberry Pi, you want to use the Imager.
That's what I did, yes.
No.
Okay, thank you. I don't want to monopolize the time or do.
And a current version of that. Leads into something that I probably should have added to this. I'll argue that the soul of any computer is the operating system that lives on its boot device. That's what makes it work. That's what allows us to put Windows on a computer, or Linux on the same computer. The same is true in the world of Raspberry Pi. This morning I had an unusual problem and I needed to move to a different Raspberry Pi for things that I might show you later. I took the SD card out of a Raspberry Pi 4, popped it into a Raspberry Pi 02W and booted that and got around the problem. I think it has to do with the network configuration. I'm not absolutely certain of that.
Over to you, John.
Okay. Since I'm hosting this, I kind of can get to control it. And so I want Curt to go on with the pie hole part, because I'm one of those guys that he might have mentioned that has a pie sitting over here for a couple years without something to do. And I've heard about the pie hole. It makes a lot of sense to me to be able to block all this junk. So we're going to part 2. Here's what we're going to do with a pie. And then I'm sure we'll have more questions and discussion after that part. So Curt, I'm going to ask you to do part 2 for me, and
Okay.
anybody else that wants to watch.
Let me find. That's not what I want. That's what I want. I love all you folks, but your window is sitting on top of my control here. Okay. Come on. Okay. A live installation. And something just went wrong here. Oh, I know what happened here. I apologize, folks. Please bear with me. That's not what I want. I'm frantically doing some window shuffling here. And I would like to give you okay, you should be looking at a web page now. It says pie hole documentation.
And that's correct.
Okay. This is from pie-hole.net. Okay, you can find the installation instructions. This is the command that I showed you earlier. Curl -s capital S capital L HTTP. Okay, I'm not going to read it again. My tongue is already tied up enough.
The bars are across the screen again. If you can clear those up, please.
Yeah, we're going to go to a different screen right away. So I'm going to take and I'm going to highlight that. Magic command, Control C, because I want it on the clipboard. And now I'm probably going to lose my share. And too many windows. Okay, you should now be seeing a browser window that actually it's not a browser one, it's a VNC window showing my Raspberry Pi, right?
Correct.
Okay, we need a terminal. I took that command and I put it on the Windows clipboard. Now I'm running on Windows and I'm controlling a Raspberry Pi. So I should be able to, I've had a little bit of trouble with this using shortcuts, but I should be able to paste. I said I should be able to do a paste. And it isn't working. So we're going to do it the other way. That out of the way. And we're about to go on autopilot. And I need to confirm this. They would like donations. Okay. To actually use a Raspberry Pi or run Pi-hole on your home network, it has to have a static IP address. That's something that we can sort of fake here or adjust after we've got it installed. For my purposes here, I'm going to say that the IP address that I have right now is a static IP address. It's not, but it's going to function like one. Okay. Okay, do I want my current network settings as static addresses? Yes, and that is my IP address on my local network. Many of you will recognize 192.168.something as your local addresses on your local network. Okay. I used to have a lot of problems because I'd go to a coffee shop and I'd connect to their network and I'd come back home and connect to my network and have a problem because the coffee shop used the same IP address ranges as my home network. So I changed my home network to use 198 or 192.168.104.something. Where'd the 104 come from? I pulled it out of the air. Okay. 104 was the street number of the house that I grew up in. So it's pretty easy for me to remember that one, at least so far anyway. I could take and change it. I'm going to say to go ahead and use it. Be just fine for us. This is just information about the DHCP configuration. We'll confirm that. I know that. Okay. We have a choice of domain name servers that we are going to connect to on that. If your internet provider probably provides you with a pointer to a search engine, you can pick any of these that are in this list. Okay. I use Cloudflare. I have more trouble saying that normally. So I'm going to use that now. It'll work fine. I use a different choice of there's a custom one, but I'm not going to bother setting that up right now. if I find the right key. Actually. Okay. This is a suggested source of a list of ad servers, for lack of a better term. We could add to that list if we wanted to. Oh, we're going to just say it's okay. Okay. Do we want to install the web admin interface? We do. That allows us to connect to the Pi-hole through a browser and control it. Okay, do I wish to install the web server? Well, if we're going to connect to it via the network, then I need to do this. I would select no to this if I already had a server running on the Pi. Okay. Do I want to see log queries? Yes. This can be useful when I'm troubleshooting if I'm troubleshooting problems. So that's fine. Show everything. Yes, I want to do that. My hands are off the keyboard. While this is going on, I will sort of reiterate something that I saw all over the place when I was looking at some documentation. The processing demands for Pi-hole are very, very, very low, especially when it's running. It will happily run on a Pi 0W, okay, or anything more powerful. And everything is more powerful than a Pi 0. Okay, we saw this before, and I'm just going to confirm it. I just saw something that I need to look up. I apologize for this delay while I look up something. On that one of those previous screens, you saw a password displayed for the administrative interface into the Pi-hole, and it was an ugly password. And I cavalierly just forgot about it, or ignored it is more appropriate. To make my life easier, and I'm going to change the Pi-hole password. And trouble, the cursor's getting in my way. Pi-hole -a, lowercase a, hyphen lowercase p. And this is a command to change the Pi-hole administrative password. Enter the new password or blank for no password. Oh, I can hit enter. Okay, the password has now been removed. Okay. Normally, I would reboot my system right now. Okay. Instead of doing that, I am going to, bear with me a second. Change my share. Okay, and you should be seeing a Pi-hole desktop running. CMT Pi-hole is the Pi-hole that I have running right now. Okay. I'm about to lose my patience here. I wanted one window, I got four. Okay. One of the things that Pi-hole will do, and you don't, I'm pretty sure you don't have to configure it to do this. If your machines are configured to use the Pi-hole as their DNS server, and we'll take a look at how you actually do that in a different window. Pi-hole can respond to DNS requests for things that don't really exist on the internet, or things that are in effectively a local DNS table. And pi.hole, you will not find it on the internet anywhere, but on my local network, pi.hole, DuckDuckGo doesn't. This is a gotcha. Okay. Oops. Okay. HTTP 192.168.104. That's consistent with everything that I told you before. 225 is the dedicated IP address that I have for my real Pi-hole. I could have put /admin on it, and it would have taken me here. Okay, I can connect to this. Okay, right now, actually, I'm not sure where I'm viewing this from. Yes, I am. I'm on my Pi-hole. Okay, I am connected to the administrative interface. But this is where I can see what Pi-hole is doing. Okay, now this is a real running one. I have it set up so it reboots every day automatically, I think at 4 o'clock, because we're never doing anything at 4 o'clock. This is protecting everything on my home network right now. I can do things like look at the query log. And if I have a problem with something that's being blocked, come on, I can look for things in here. Here are some things that are coming from systems in my network that are being blocked by Gravity. Is the facility within the Pi-hole that lists things that we don't want to go to. Okay, here are other things. It looks like my wife might be doing something with genealogy right now, but these are requests that are going through here. This Pi-hole has been configured to use a static IP address, and when I get through here, I'm going to take and show you how that's set in my router. Every router is different. Okay. Something that is useful here is this disable facility. One of the companies that I get regular email from is Micro Center, and I don't mind getting their ads. Okay. They serve the images that are in their ads are coming from an advertising server that Pi-hole doesn't like. So when I download images for email for a Micro Center ad, I don't see any of the pictures, which are sometimes necessary. So I can go over to my Pi-hole and I can disable it. What I usually do is come over, disable it for 30 seconds, go back to my email program, say download the images. 30 seconds later, it'll get turned back on, and things are just fine. Okay. Settings is useful, I believe. That's where I want to show you something anyway. Okay. DHCP. Nope, that's not what I want. This is what I want. This is what I wanted. When I installed the Pi-hole, you saw me select Cloudflare as my DNS server. Okay. I've got custom DNS servers set here. These actually are Cloudflare servers. They are not the standard one. These servers are set up so that they will block access to malware sites. You can also have them block access to things that are not child friendly. My attitude is such that I really don't need training wheels, but I would like you to block things that are known to be bad from me. So I have looked up and I changed these settings, but you can use the upstream provider of your choice. Okay. I was given a subscription to Paramount Plus, a streaming service. Okay, came from T-Mobile. Gave it to me. And I thought, what a nice service I can take, and I can watch it on my Fire TV sticks or my Roku stick. And every time I started it up, it said it had a problem with the internet connection. And that's because the low cost tier of Paramount Plus serves ads. Okay. Rather than take and track down all of the servers that they might use. Okay. I sent my those devices, the streaming players, okay, to use dedicated IP addresses identified by their MAC address. Now that's a hardware device, hardware address on the device itself. Okay, so here's my first Fire TV, there's my second Fire TV, there's my Roku streaming stick. It's not terribly important what IP address that I set for them. What's important for them is that they are identified by IP or by MAC address, and I have created a group called Fire Sticks and Roku for them. Okay. Now we go to groups. And down here to Fire Sticks and Roku, that's a group. The status is disabled. Okay. Fire Stick or Pi-hole will not restrict any access from those devices. Everything else is in the default group and they're enabled. Okay. I just saved you a lot of hair pulling should you use services like Paramount Plus, but likes to serve ads, and you sort of have to grin and bear it. Is there anything else in here I want to show you? Talked about the query log. Okay. I am going to, the black bar is going to come back for a second, John. Do a new share. And let's take this browser window. You should be seeing a Firefox window that says Pi-hole on it. Is that correct?
The one for resetting.
Yes. Okay. Okay, this is my internet service is provided by CenturyLink, unfortunately, sort of, but it's the best choice I have right now. I've got the credentials entered into the router so that I can go in and look at advanced setup. Now, this is important. A couple of things here. Local area network DHCP settings. Okay. DHCP is enabled, which means that when a device connects to my network, it's going to go through DHCP on the router. Okay. This is the modem address that's set in there. And is this the page that I wanted? Yes, it is. Okay. This is the beginning and ending address range for dynamic assignment, the subsystem mask. Okay. I use a relatively short lease time of 1 day. Doesn't really make too much difference, but that's what I do. Okay. Okay. Set the DNS servers allocated with DHCP requests. So when one of your computers connects to your network, it does a couple of things. It asks for an IP address to use, and it also asks for, or gets anyway, domain name server addresses. Okay. 192.168.104.225 is that dedicated address for the Raspberry Pi that runs Pi-hole. Okay. The secondary address that I have here is one of the Cloudflare addresses. I would come in here, and if I set apply on this, it's going to restart my router. Don't want to do that right now. So, and I think we will see in DHCP reservations. Yep. We will see a list of devices in here. These are the MAC addresses of those streaming devices, okay, along with the assignment of the IP address they're going to get. Now, my Raspberry Pi itself is manually configured to go to 225, and 225 is not in the dynamic range, so that'll always be available. So with that, I'm going to stop my share and do some screen shuffling to find. Get some screen clutter out of the way. I apologize for that. And we'll take questions on that.
Well, the number one top question is going to be, you're telling me that using that Pi-hole, you've seen a drastic drop in junk.
Yes.
Do you see it more so than just doing your router setup for Cloudflare?
There are, Cloudflare does not do any ad blocking. If it's going to block anything, it'll be a site that is being blocked because of either inappropriateness for children and families, or because of inappropriateness because it is known to host malware. Okay, that stops everything. What Pi-hole is particularly good for is stopping ads that you see coming from websites. I am not sure if it will block ads in YouTube. It might. Okay. But I have a subscription to YouTube, so I run with that, and I don't get a lot of embedded ads. It stops ads from websites. One class of website that's kind of notorious for showing ads are things like newspapers. You go to a newspaper site or a news site to read a story, and every 3 paragraphs there's a great big picture of an ad in it. Okay. With Pi-hole, either that space will not show up at all, or it'll show up and be empty. There is a website called speedtest.net by Ookla, I think. If somebody wants me to demonstrate, I'll be happy to do that. It serves a lot of ads along with its speed test. But if I go there, I don't see any of its ads on the screen around the content, which is really what I went to that website to see or to do. So that's the place where I find Pi-hole to be particularly useful. It doesn't throw that junk in front of me. Okay. One other thing that I will note to you. if your browser is set up to use Google or to use the Google search engine, I should say, when you get your search results back from it, the top, I don't know how many, if you look carefully, you'll see that they're indicated as being an ad. They are placed there because somebody was willing to pay for them to be placed there. If I click on one of those, I am going to get an error that says I can't get there. And let me sort of explain about how Pi-hole blocks things. And also why its resource consumption is so low. When your computer goes to the internet to find a website, it has to take and convert that domain name into an IP address. That's what a DNS server does. Okay. So when something in your network is configured to use your Pi-hole, now with the way I have it set up in my router, everything that connects to my network uses the Pi-hole. That request goes to the Pi-hole. The Pi-hole says a couple of things. Have I responded positively to this request before? And if so, it goes back. Don't have to do anything else. If I haven't, is it on a list of blocked websites? If it is, it sends an IP address back to the requester, typically the browser, and says, hey, it ain't there. Okay. But if it's good, it passes back the real IP address that it gets from Cloudflare or Google or whoever you choose to do it with.
Okay. At this time, we can accept discussions and comments and questions from anybody out there. If you have something that you would like to share or talk about, use your reactions, raise your hand. Unless Judy, unless you have a question, I've jumped ahead of you.
I have two.
Okay.
Can you use the VNC client and the monitor/KBD/mouse at the same time?
When I'm using VNC, I click that window, I am seeing the monitor. Okay. My keyboard is connected to it, so is my mouse. Now, could I also have another monitor on the Raspberry Pi? The answer is certainly. Could I have another keyboard plugged into it? You betcha. Same thing with the mouse if I wanted to. But the whole point about what we're doing here is to minimize what we have connected to the Raspberry Pi.
Cool. I have one comment, and then I have one last question. Raspberry Pi came out on February 29, 2012, so it's not very old if you count every 4 years. And we had our Raspberry Pi presentation at my group in summer of 2012. And we just all sat there with our mouths hanging open, watching what Chuck LaForce was doing in front of the room. We absolutely couldn't believe it. And Curt, what Chrome browser version are you using?
Whatever the current one is.
Good answer. Over to John.
Okay. So we'll see if anybody else wants to share other projects that they're doing with their Pis, because that's just the easiest one to me. That just says I'm going to be able to set up a Pi back here in the corner, wirelessly, and with one power plug, set it all up, and I've got myself a super duper ad blocker, which is going to be great. But there are a lot of other things. Actually, you can run it as a regular computer, If you don't have the money to buy a computer, you can buy the small one and it works just the same. So if there's anybody that has comments or ideas to share with us, we're glad to have those.
I'd like to make
Go
a
ahead.
comment. The reason for this presentation, okay, is not necessarily to show how to run a Pi-hole, although that's a good application to run on it. And you can plug it in anywhere. You got some extra space in the bathroom, do it there. You got space in your attached garage, do it there. You know, it can be anywhere. You don't need to be able to get to it very, very often on that. And the other thing is that this is a tool to learn that can be used to learn how to do things on a Linux machine, whatever that is. Do you want to see if you could use it for your office applications? Yeah. Do you want to use it for as an email client? Sure, you can do that. Put Thunderbird on it or something like that. This is an easy way to get you introduced to a Linux operating system with a minimum of cost and a minimum of cables, 2 at most. So,
Yeah, that's great. Judy, you have your hand up.
Yes. If my member SCV Computer Club, Dave Melton, was here, he would remind us that he uses Raspberry Pi for his sprinkler system. And he gave a presentation to us earlier in the year on this. And we now can water 3 days a week, Monday, Wednesday, or Friday, or Tuesday, Thursday, and Sunday for 10 minutes. And I know that he's had to reprogram that thing from the way he set it up in the first place. Craig, you're on.
Well, first of all, Dave was at our Linux SIG meeting last night, courtesy of you. So thank you, Judy, for passing on the link. But I have 12 or 13 Raspberry Pis, and each one of them has a job. One of them, probably the most unusual one, is I have one bolted or screwed to the wall in my garage next to the garage door. And it will let me use my phone via a website that's password protected to let me open and close the garage door from anywhere. So a couple of times my neighbor across the street would text me and said, "Did you know that your garage door is up?" And I said, "Won't be for long," because I left and forgot to close it. So that's probably one of the more unusual ones. And I have Pi-hole, I have a web server. So yeah, I guess I'm a total Raspberry Pi geek here.
And your mirror?
Oh yes, my magic mirror. It's basically a piece of, there's a sort of like a picture frame around it. And there's a piece of two-way glass like you see in the TV shows where the cops are looking through the room into the interrogation room. And behind that is a monitor that is being driven by a Raspberry Pi. And it displays weather information and upcoming meetings and things like that on that screen behind what looks like an ordinary mirror.
let me make an observation. It is quite likely, if you've got other Raspberry Pis that run all of the time, that you could take and run your Pi-hole on your magic mirror.
Yeah, I probably could. But the machine that's running my Raspberry Pi, or that's running Pi-hole, is actually a Raspberry Pi 1B. So it's pretty slow. The magic mirror, I think, is on a 3. And I actually have a Raspberry Pi 4 with 8 gig of RAM that I use as a general computer downstairs. So that's just has a monitor and mouse and keyboard and an SSD drive and it works very well. And Judy has seen this document before, my manual, the unofficial setup guide for Raspberry Pi, which includes a lot of the stuff that you talked about, Curt, plus a whole bunch more. And that's available. And I will post the link in the chat so that everybody can get that.
Thank you. Thank you. Over to you, Kevin.
Thank you so much. Curt, this has been terrific. Thank you so much for just a wonderful presentation. Really, really excellent. I don't know if I should, I've got 4 questions and I'll just ask as many as I can, and Judy, just cut me off when I talk too much. On the Raspberry Pi 4 and on some of the others, I think there's USB 2 and USB 3 ports. And I noticed that when I work on a Windows system, sometimes I can't load Windows on a machine through a USB 3 port. I have to load it on a USB 2 port. And I was wondering, why does it have both? Are there limitations to the USB 3 ports under certain circumstances that you have to use USB 2? Or does it cost more, or to do all 3? Or any thoughts on that?
The support requirements for USB 3 are greater than for USB 2. Okay, so it is more taxing on the processor to support USB 3 ports than it is USB 2 ports. There are devices that don't really care. Keyboards, mice, webcams probably will not perform any better on a USB 3 port than they will on a USB 2 port. But USB 3 ports are faster for things like thumb drives. I'll also note, and I don't have at the top of my memory a reference to this, but I believe the Pi 3s, and I know the Pi 4s can have firmware updates. And one of the firmware updates for some Raspberry Pi 4s, those that don't have it natively, allows you to boot from a USB device, whether that be a thumb drive or an external hard drive or an SSD or whatever. I have done that just so that I can say that I did it. There are discussions about whether that's really faster or not, whether it's better to, whether you get better life out of a thumb drive than you do an SD card and things like that.
Thank you, thank you. And then what's is the SD card slot for that Pi 4, is that like an SDXC card so it can handle up to a terabyte, or
I don't know offhand what the limit of it is. I think I am fairly certain it's good to at least 256 gig.
Okay.
And it is a micro SD card.
Oh, thank you. I was wondering about that. Okay. Okay, and then the what version of Linux does the Linux run that you chose? There were 3 of them, and you said you chose the middle one.
Yeah, the one that I chose, I didn't choose it because of the version of Linux. I chose it because of the facilities that were on it. It's the minimum of those 3 that has a desktop on it. And it's not as big to handle as the one that has the recommended software on it. Anything that I want to install, I can install on the sort of standard version. And I don't have that at the tip of my tongue. If you go to raspberrypi.com, the software, you can see the version on that.
Okay, thank you. And then the last thing was, I noticed when you were doing the configuring of your CenturyLink DSL modem router guy, that you did use Cloudflare as the secondary DNS. Yep. And I was just wondering, I'm used to seeing, you know, Spectrum where they just have their 2 consecutively numbered DNS servers. And does it actually, I was just wondering why you use Cloudflare as your second server.
Because I trust them more than I trust CenturyLink.
Well, it's also
And
the back-
CenturyLink doesn't need to see what I'm doing.
yeah, it's
Oh,
also
it
the
wasn't-
back.
It wasn't why are you not using CenturyLink? It was why did you choose Cloudflare? Because that IP address just knocks me over with the 1.1.1.2. It's like, whoa, that's just like the beginning of time.
The backup is 1.0.0.2.
Wow. Wow.
Cloudflare,
Doesn't track,
say again?
doesn't track.
But also Cloudflare has some options to take and block what I'll grossly call malware. Okay, that being things that support malicious software. And it has an option that is also what I'll call family friendly. Okay, I don't choose the family friendly one. I don't have small children or grandchildren that I need to be concerned about. And I'm a big boy. I'm not visiting porn sites, but I don't want anything that I want to go to stopped unless it's malware.
Gotcha. Perfect. Thank you so much. I really appreciate it. Great presentation.
Curt, I think the one question might have been, don't we have an option now that we don't have to use Raspberry Pi, that we have a lot of other Linux versions that will work on a Raspberry Pi, but you're choosing to go with the de facto Raspberry Pi OS to go on the Raspberry Pi?
Yes. Because I've always done it that way. Also, I should point out that if Pi-hole is the thing that you want to run, you can run it on probably any Linux distro, on any Linux machine. It doesn't have to be on a Pi-hole. And if you want to think of the Pi-hole, think of it as something that just, it's a gateway to nothing. It just goes away.
Over to Craig. Unmute, please.
I had a comment on the micro SD card size. Some of the older Raspberry Pis won't boot if that micro SD card is larger than 256 gig. So don't get a huge card. 32 gig or 16 gig is plenty. 32s are pretty cheap, so that's what I usually use.
Micro Center is sort of our local purveyor of reasonably priced, cheap SD cards.
I went into the Micro Center, I don't know, 6 months ago, and I wanted to buy a couple of 8 megabyte or 8 gig cards, and they said we don't sell them that small.
Yep, and the same I think is probably true for 16s now.
And at that time I said, well, what's the smallest one you sell? And they said 16. I said, how much are those? And this was a Micro Center brand, and they were $359 for each one.
Yep.
And I said, well, how much for a 32? And he goes, $399. Now the prices have gone up slightly, but a 32 gig one is still less than $450. I mean, it's only gone up a few cents. And yeah, the 16s might not be there anymore.
I love to see people's reactions when you said how much they cost.
Yeah, they're almost ready to break my budget because I am retired now.
Oh, stop. I think we're going to go over to Cal now. Is that correct, John?
Well, we'll see if Cal wants to share with us an update on his workings with a Pi. Are you there, Cal? He's got his mic on.
I guess not. Hey, you guys that use Raspberry Pis out there, and I know who some of you
okay.
are. Do you want to talk about
Wait.
what you're using them for?
Wait a second, I just found Cal's picture and his hands kind of went up in the air.
I know, he said he doesn't have any sound.
Uh-oh, okay. We'll go back. Yeah, anybody else that wants to share with us today?
Come on, you guys that I know you involved with Raspberry Pi. Tom, go for it. Don't forget to unmute.
I use one to back up my Mac computers for Time Machine and specifically, and so it backs them all up automatically.
Very good. Oh, I think Cal has his sound, maybe.
Test.
Okay, it's a little bit,
Little bit loud there.
Sounds like you're inside your vacuum cleaner.
I was gonna say the ocean, but okay, I'll go with vacuum cleaner.
It sounds like there's two volume controls and one is turned down fairly low and the other one is turned out very, very high.
Your mic is probably set too low.
I'd say he's frozen.
Oh no, the other way around. Your speakers are probably too low.
I say he's frozen in time.
mic just went off, now it's back on.
Oh.
But yeah, he hasn't moved.
Okay, come on, you guys that use a Raspberry Pi for something. We don't bite, you know.
Test.
There he is. Hi,
Okay.
Cal.
All right. Let me see if I can share something.
Sure.
Please do. Oh,
Okay, so what I was doing is just using it as a regular computer for demo purposes. And I know there are alternatives, but I found this works in certain circumstances. But the real reason I'm gonna keep with it is because there are a lot of other single board computers coming out, and I'm trying to keep in touch with that. And so here's my system. Just hooked up. It comes in a case, as was discussed. And I generally use the USB drives. And I've used Ubuntu, Fedora, Pop! OS, and I've even worked a little with Manjaro, but that's in Arch, and I'm still not ready for Arch. And for everybody knows that the software has to be compiled on the appropriate instruction set architecture. And Windows, of course, uses x86, and the Pi uses, as I was talking about, the 32-bit uses ARM-HF, but for 64-bit, it uses AArch. And a lot of distributions are using it, but not everybody. So how do I get it? As you know, I found the Raspberry Pi imager is great, and you get a choice right off the shelf. They give you Ubuntu, and they have the latest 2204. But I like to do them custom. I go get the ISO first. And so you can see that Ubuntu now has a dedicated system. And, you know, I like to go to the who's ever doing the distribution if I can. And notice they have the Pi 4, the 400, And if you have a control module even, which is for embedded, you go to Pop OS. Anybody who wants I did that because I have a System 76. If you have a System 76 computer, or if you're thinking about it, Pop OS is what they use, and it's all Linux support. And I went to Fedora, and they said, well, it's not supported, but it works. So I said, okay. And they said you'll get poor acceleration. And they also, I can't get what I want to see here. They have a lot of other boards that they support. There must be 100 boards out now. And Fedora says they support about 50 of them that are not Raspberry Pi. Now, one of the things I ran into working with it is that if I go and put an image on a large drive, it doesn't use the space. So here it's only, I have 7 gigabytes of space on a, whatever this is, 124 gig drive. So what you have to do is go and open it up and use gparted on another machine so that you can get it and repartition it. And I found this on a couple distributions. And after it's completed, here I've expanded the space to, you know, whatever I want, in this case, 80 gigs. And you can check it with the normal disk manager when you're running. Of course, you have to run gparted on another machine. And the power, I've looked at this, you know, and the power is a lot less. It used to be, this is like 2017 boards, you know, they could go up to 65 watts. The new 12th generation is using a lot less, but the Pi, even if you overclock it, it maxes out a little above 8 and normally runs 2 or 3 watts. So if somebody wants to run this off of solar cells, or, you know, this is a pretty good approach. And if we remember back with our PCs, used to have these great big power supplies, 250 watts. If you want to compare what you get in a laptop, you can see that here's some, I don't know, some modern, you know, last laptops of the last couple of years, and they can be 90, 65, 45 watt bricks, you know, chargers. I use that as a kind of a, what did they expect out of this machine? And the cell phones, they're always run about 5 watts. And as Curt was mentioning, you know, you get a fast charger. The cell phone doesn't need it, but it charges it fast. That's 10 watts. And your Pi is about 15. So what I found is the Pis, they work. You can use them as a desktop. And if you want to really get some software, snaps and flat packs, the containers are really way to go on a Pi. And Ubuntu and Pop OS really work well. And Fedora, Fedora is Fedora. You got to do a lot more command line to get everything to work. And I'm not, and if you use Arch, you've got to do everything yourself. And I wasn't ready to do that as a demo. So I did find that the first Ubuntu for the Pi was 2110, and it did update to the 2204 this month. So they've got that working. Pop OS is still hasn't passed their upgrade yet. And Fedora, I installed it from the ISO, and I put both GNOME and KDE desktops on it. It works all right. So really, I'm doing all this because I want to get a different single board controller system on a chip system when I think they're ready. So that's kind of what I found out in the last 5 or 6 months since I talked to you last about my Pi.
That's
Thank you.
good. Yeah. I want to make a comment, on the purpose of part of the purpose for this workshop when we were talking with Curt about it was that we've had a lot of discussion in previous ones about how to test out Linux, and people want to dual boot, and there's always some issues with that, booting off of your thumb drives, and there's some problems with that. But Curt said this is the such easiest way for 15 or so bucks to get that on, and you're running Linux, not having to do a dual boot install or anything else. So it's really a great way for people who want to try out. And since it's on an SD card, you can just install a row of them, and then you just pop in the version that you want to try out and pop out and try a different one.
Right. That's what I do. I'll put one in and take it out and put another one in and take it out.
Hey, John, it was interesting to see a Canadian Voice was this and showing us something, and he agreed with almost every single thing you said. And Cal, what was that little thing that you held up?
What little thing?
Cal, K-A-L.
Oh,
What I have done is I've put a live version of Knoppix Linux, and it has what they call persistence. And what you can do is read and write to it, so it can actually save your files to it. And it's a 16 gigabyte USB drive on a metal Kingston flash drive. I use it all the time.
Good grief.
In conjunction with what the Cal C was saying, I just happened to plug in my Pi Zero 2W through a connection that has a little volt and ammeter on it, and I'll try to take and show it.
Okay, we can see it.
It'll be hard to see, but the voltage going into it is 5.0, and the current right now is, I think, 140 milliamps. Okay, that's roughly an eighth of a watt. So this is using less than a watt. Okay, 5 times, it doesn't want to stay on my desk. 5 times 0.14, okay, watts.
Craig.
Obviously, that means that if you want to run something all the time, like Pi-hole or whatever, running it on a Pi is going to cost you a lot less energy to run it than running it even on a low-end laptop or desktop machine. And that's why I run a lot of stuff on Raspberry Pis, because they use all of them together, probably use far less than a 100-watt light bulb. Probably about 20 watts for all of them.
I'll make a note about the chargers for portable devices, particularly laptops. Okay, you may have a 45-watt charger. Okay, that might, if the battery is dead, consume 45 watts of power. But if it's just being used to run the laptop, not charge the battery, the power consumption is going to be way less than that.
Yeah, right. And that's what I said. This is simply a guide to rank those computers. In fact, the new 12th generation is, their thermal design power is maybe less than 10 watts now because they have the low cores and the high efficiency cores. So everybody is going down, but the Pi, all these ARM chips is still way ahead of all the Intel brands.
And they generate far less heat too.
Well, that's the whole point.
Yeah.
Okay, calling. I still know there's still people out there. I see on your meeting announcements that you're doing something about Raspberry Pi. How about sharing that information with us? We don't bite, honest. We won't ask you to give a presentation if you just happen to mention something.
That's not what happened. to
That's
me.
what happened to Curt. Sorry, oops.
And Craig. Yep.
Yes, Curt answered a question to John, and John said, thanks for offering to give a presentation.
It was useful.
Mhm.
Yeah, this has been good.
Okay, you guys, going.
I will mention that next week we kind of continue like on a, the movie channel or AMC, the theme of network, that today we were connecting a headless Pi. Next week, Curt will be here and we will be talking about network access storage. So hopefully a lot of you will be back. And we're working on June and July. If you have suggestions for workshops, or you'd say, hey, I've been watching these, I can do it.
And
Please.
Judy,
Yes,
the dates you proposed, the July one is the preferred one?
July, thank you so much. Gee, I stopped by their meeting and, found a good
Next thing I
presentation.
know, hey, would you like to do this presentation again?
And he's already got it aced. I mean,
I've
and-
done it 3 times.
Yeah, and it's about Mac stuff, and we don't hardly get any stuff for our Apple folks. So
We're going to add a
it's really
couple
good.
slides for the APCUG one because AirTags have had some revisions.
Good, that's
So
great.
we'll add those, and yeah, we're ready to go.
All right.
Super. I will put you in ink, so to speak.
Yeah, Deborah and I both will be there.
Great. And I just need short bios from both of you.
Okay,
Okay.
But-
I suppose I can come up with that.
Oh, God knows, yes. Bud,
Yes, I think it was Craig mentioned he had a little manual or something. He was going to put a link in the chat.
he
And
did.
I
haven't
did,
seen-
but I can't send it to everybody.
I will be sending it out with other links.
Okay, thank
I'll
you.
tell you, it's a good one.
Yeah.
It's up to 170 pages
Oh,
now.
that was going to be my line. It's not that it's short.
Okay, thank you. I appreciate it.
Any other questions? Any other feedback? Any other ideas for John and his team for Linux workshops? You'd love to jump in and do a little something sometime?
Craig's manual covers a lot, and it'll take beginners in Linux all the way through doing stuff on a Raspberry Pi.
I think there's even a block in there on how to install Pi-hole. I'll have to look.
And how long, when did you start the book?
3 years ago.
Okay, I guess it's not a book, it's a manual, a how-to manual.
It's got to be longer than 3 years ago, Craig.
Maybe
Yeah.
4.
Yeah, I think so too. Anyway, John, take us away.
All right. Thank you, everybody. I'd like to thank, of course, always Bill James being there just for in case of, Judy for asking questions, Curt, especially for a fine presentation. I'm ready to get my little Pi out because I can plug it in anywhere.
Oh, good.
Yeah.
It's right behind you on your screen.
Right.
Yeah. But it's over. It's in the box. It's been in the box for 2 years because of COVID, and so I've got to get it out. And to thank Orv and Cal for being here too for some other support. Thank you, everybody. We will see you, most of you, probably next week, and then we will be on to June already. Half a year almost already.